All right, so welcome back. I understand that you probably can't pair share because of the coronavirus, but I do want you to take a moment and I want you to try this problem on your own and then check back in. So part A says find dy dx. Remember, that's just an alternative notation for y prime. Find the derivative. Where y is defined now implicitly as a function of x by this equation. Notice here we're not able to solve for y. We got y squared here and y here, so we have to use implicit differentiation. Okay, A. So the steps of implicit differentiation, step 1 is to just take the derivative of both sides with respect to x. Differentiate both sides. Okay, so here I am. I'm going to take the derivative of the left-hand side and the derivative of the right-hand side. Okay, just take the derivative of both. Right? When I look at the left-hand side, I want to see how it's constructed. It's one function of x minus another, so I get to go ahead and differentiate term by term. The derivative of x squared is 2x, minus the derivative of x is 1, minus the derivative of 2 is 0. The derivative of 2y squared is going to be 2 times 2, which is 4, y to the power of 1, chain rule. Since y is a function of x, I'm multiplying by y prime. Oops. Minus the derivative of 2y is 2, again, chain rule, times the derivative of y with respect to x times a y prime. So remember, when you're taking the derivative of y stuff, it's just like when you're doing the derivative of x stuff, but you hit it with a y prime right after. That is happening with the x's as well, but x prime is just 1. Okay? So here we have, just drop my color. I want to solve for y prime. I want to solve for the pink. Step 2. Just using algebra. I already have the pink on one side of the equation, so what I'm going to do is I'm just going to factor out that y prime, factor out pink. All right? Y prime times 4y is 4y prime, and y prime times minus 2 is minus 2y prime. 4y minus 2 times the thing I'm looking for. What's the opposite of multiplying by that? Dividing by that. And what I do to one side, I do to the other. Divide both sides by 4y minus 2. And we are done. We have 2x minus 1 all over 4y minus 2 is equal to y prime. There is no side to equalities. Beautiful. I now, in part B, am going to use that function. I'm being asked to write the equation of the tangent line to this thing's a hyperbola, at the point minus 6, 5. So, to write the equation of the tangent line, remember y minus y1 is my slope times x minus x1, and we know they gave us the point. That was nice. when x is -6, if we plug in a -6 in here and solve for y, we find out that y is 5. So that's my x1 and my y1. x1 is -6, y1 is 5. Y minus, y minus my 5 is equal to my slope times x minus x1, which is a -6. How on earth do we find the slope? Well, we use part A. This function right here gives me the slope. Of the tangent line at any point on that parabola. I specifically want it at the point -6, 5. I think I'm going to do that on, oh, I should insert a page. I'm writing a little big. Okay. So your slope is y prime, which is this 2x minus 1 all over 4y minus 2, and I'm going to evaluate that when x is -6 and y is 5. We get 2 times a -6 minus 1 all over 4 times 5 minus 2. What is this? -12 minus 1 all over 20 minus 2. We get -13 over 18. And we're ready to put it all together. The equation of the tangent line is y minus 5 is equal to -13/18 times x minus a -6, x plus 6. You could go ahead and solve for y if you wanted to. I'm just going to leave it like that. Okay. Let's go ahead and see this on Desmos, that we are in fact correct. Here is my parabola, and here's the point -6, 5. The slope right here is looking like about -7.2, maybe about -3/4. In fact, what is it exactly? We know because we just solved it. It's -13 over 18. Beautiful.